Hello everyone, welcome back to my channel. Now in the series of MCQs on analog electronics, we'll be looking forward to 20 more questions. First of all, the question asks that which of the following is a semiconductor material? So the answer is D, that is silicon, germanium, gallium arsenide. All of these are the semiconductor materials. Next, LED produces light when it is forward biased or reverse biased or unbiased. So the answer is it is forward biased. When LED is forward biased, it will produce light. Next, a Schottky diode is a majority carry device, minority carry device, fast recovery diode, or both a majority and minority carry diode. So the answer is Schottky diode is a majority carrier device. We know that Schottky diode is formed by joining a semiconductor region, usually N-type, with a metal such as gold, silver or platinum. So it is a metal to a semiconductor junction having only majority carriers. It is also used for high frequency switching applications above 20 GHz. Next, when a junction diode is reversed biased, then the diode acts like a open switch. So when the junction is reverse biased, the thickness of the depletion region will increase and the diode will act as an open circuit or open switch blocking any current flow. Next, what is the charge of mobile charge carriers of holes? So the answer is C, that is positively charged. We know that holes are positively charged while electrons are negatively charged. So deficiency of one electron is considered as hole or the positive charge. So it is positively charged. Next, when a junction diode is forward biased, the thickness of depletion region is larger, smaller, medium or not determined. So the answer is it is smaller. We know that forward voltage will push more free electrons into P region and holes into N region. This makes the depletion region smaller and starts conducting the current. Which are the mobile charge carriers present in semiconductor diode? So the answer is D, that is both A and B. Holes and electrons both are present as mobile charge carriers in semiconductor diode. Next, diode is also called as, so the answer is it is known as rectifier. Rectifier is that which converts the alternating current, periodically reversing the direction to a direct current. So the process is known as rectification. Diode works only in the positive half of the input but doesn't work on the negative cycle. So single diode work as half wave rectifier. Next, when p-type substance is connected with negative and n-type is connected with positive of a battery, then p-n junction diode is reverse bias, because when p is negative for forward bias region, we know that p should be connected to positive and n to the negative, whereas in this condition p substrate is connected to the negative, so it is reverse bias. Next, what is the majority carrier in n-type material? So the answer is electrons are the majority carrier in n-type material. Next, which are the ways to convert an alternating current into direct current? So the answer is we can use half wave rectification, center tap or bridge. All of these three are the classifications of rectifiers. So the answer is D. Next, which is the third region where no charge carriers are present when n-type and p-type are attached together? So the answer is B, that is depletion region. When two materials, that is n-type and p-type, are attached together, a momentary flow of electron occurs from n to p side and holes from p to n side, resulting in a third region where no charge are present and they become immobile. Next, which type of device is a diode? So the answer is semiconductor. So diode is a semiconductor device which has a characteristic of allowing the current in one direction and blocking in the other direction. Next, how many terminals are present in a diode device? So the answer is two terminals are present. Next, the number of valence electron in silicon are. So the answer is 4. We know that silicon has 14 electrons and the distribution is 284. So the outermost shell has 4 electrons. Next, what will be the potential barrier for silicon diode? So the answer is zero point 0.7 is the potential barrier at 300 Kelvin. Which is the conversion of current done by diode? So diode converts AC to DC. We know that it converts alternating current to direct current, that is flow in only one direction and blocks in the other direction. So it becomes unidirectional or DC. So AC to DC. Next, the number of orbiting electrons in germanium are. So the answer is 32. That is, we know the configuration, that is 2, 8, 18, 4. So the valence shell has 4 and the total number is 32. Next, what will be the potential barrier for germanium diode? So the answer is B, that is 0.3 volts, that is on 300 Kelvin. Next, when will be the PN junction formed? So the answer is when two opposite doped materials, when there are two opposite doped materials. So PN junction are formed at the point at which the oppositely doped materials P and N type are fabricated in a special way. So this was all about this lecture. In next lecture, we'll be looking forward to 20 more questions. Till then, if you like my videos, then do subscribe to my channel. And if you have any doubt, you can ask me in the comment section below. Thank you.